Hello, Alan. Hello, Alan.
Yes, sir.
In the last in the last test, you got around 100 in physics, isn't it?
Yes, sir.
Good, nice marks. In total,
Total I got like 590.
very good. Alan, Farhad. Let all of them come. Then we'll start. All right.
Yes, sir.
We'll start with a new topic, that is electric field. And last time we discussed up to equilibrium. Is it fine? And today I'll try.
Yes, sir.
Today I'll try to complete the entire chapter. Am I visible and audible to you? To everyone, sorry.
Yes, sir.
Okay. Let all of them come. Then we'll start. Farhad, how was your exam last time? How much did you get in physics and in total? Farhad, am I audible to you? Saifullah, am I audible to you? Mamuna, am I audible to you?
Yes, sir, you are.
Okay. Saifullah, how much did you get last time in last test?
In this NEET exam, sir.
Yeah.
1 minute, sir. Check and say you.
Sorry. Okay, great.
Yes, sir. I got 111.
In physics?
Yes, sir.
Very good. And in total?
Total, I got 426.
That's fine. Try to improve.
Yes, sir.
Two participants are left. Mamuna, Hiba, Farhad, Alan, Saifullah. Two to 3 minutes more. Mamuna, how much did you get in the last test?
I got 10.
10? I didn't get it.
104.
104. Good. And total?
463.
Great. All are good. Just a minute. Now, let's start with a new topic, that is electric field. And everyone knows what is electric field. Sorry. Okay. Now, electric field. Let it be two charges. Let it be two charges. Please r distance apart. So let it be two charges. Please r distance apart. Either they will experience the force of repulsion or attraction. But how does it happen? There is no physical contact between them. So there is something. Actually, what happens? A charge always creates an imaginary space around it. Imaginary space around it, due to which if we bring any other charge nearby it, so it experiences a force. So that space is known as electric field. All right. So it's basically electric field is a non-contact force, because if you place two charges are distance apart, and if you place them, either they repel or attract each other, but there is no physical contact between them, but still they will experience a force. That's something is known as that space which creates a charge around it, imaginary space, that is known as electric field. Is it fine with everyone?
Yes, sir.
Yes, sir.
Saifullah, Maimuna, if you have any doubt, anyone have you doubt, please ask me. So electric field basically it is a space. Electric field is a space around a charge, and if I bring a charge nearby so let it be this is a source charge. This is a source charge, and this is a source charge. It creates an imaginary space around it, and if I bring this charge nearby it, then this positive test charge will experience a force due to this electric field, but still they are not in physical contact. Now, electric field is a property of a single charge. It is a property of a single charge. And let it be, this is a source charge. Source charge means the charge which creates a space around it. And this is a positive test charge. Positive test charge is very, very, very small, almost negligible. It also creates a space around it, but comparatively, the strength of the electric field due to this charge is almost negligible. Now, electric field basically, so electric field is intensity is defined as this force per unit test charge. Limit Q tends to 0, force per unit test charge. For 1 coulomb of charge, E equals to F. Its SI unit is Newton per coulomb or volt per meter. Now, electric field due to a point charge. So electric field due to a point charge is equals to KQ over R square. E inversely proportional to R square. Just this is R square. So E inversely proportional to R square. And if I plot the graph between R, and E, then it would be hyperbola. Because if we increase the distance, the electric field will go on decreasing. Is it fine till here to everyone?
Yes, sir.
Maimuna, are you okay with it?
Yes, sir.
And if you find I am teaching you so rapidly, so you can ask me. All right. Is it okay with everyone? Shall I proceed?
Yes, sir.
Yes.
Okay. It's all about the derivation. Direction. So if I can, what is the direction of the electric field? So if it is a positive charge, the direction is away from it. And if it is negative charge, then towards it. Fine. So if I ask, so this is a positive charge and this is point P. Maimuna, if I ask you what is the direction of the electric field at point P due to this positive charge, so what is the direction at P? Maimuna, what is the direction of the electric field at point P? Right or left?
Left.
Left. Means according to Maimuna, this is along left. Okay. Now, Alan, what is the direction?
Yes, sir. Of
Sorry,
direction of.
I could not understand.
No,
Sorry.
what is the question?
The question is, what is the direction of the electric field due to this positive charge at point P?
Sir, right.
Right. Saifullah, what is the direction of the electric field at point P?
Sir, right, sir.
Right. Just a minute. Hiba, what is the direction of electric field?
Sir, right.
Right. Good. Maimuna, look, if it is positive charge and if I have to calculate the direction of the electric field at point P, any of the point nearby it, so due to positive charge, it is always away from it. And due to negative, if it were negative, then towards it. Is it okay?
Yes, sir.
Don't get confused. Now, next. Till here, is it okay to everyone?
Yes, sir.
Okay. Now, as I told you, electric field is, if I have to plot the graph between distance and electric field, then if I have to plot the graph between distance and electric field, it would be hyperbola. If I plot R versus E versus R graph. Fine. It would be the shape. Now, if I have to plot the graph between E versus 1 over R square, so it would be directly proportional. Just remember one thing, 1 over R square, the graph will be directly proportional. Okay? Is it okay with everyone?
Yes, sir.
If I have to plot the graph between R and E and R, then it would be hyperbola. And if I have to plot graph E versus 1 over R square, then you have to assume as directly proportional. All right. It means you can assume the entire quantity, let it be C, and E is directly proportional to C. And if I have to plot the graph between E and C, then it would be like this. Okay, it would be a straight line. Fine. But if I have to plot the graph between E and R, then it would be hyperbola. Is it okay with everyone?
Yes, sir.
Now, this is the question. Now, what is the direction, Heba? What is the direction of the electric field due to positive charge? What is the direction? Heba, what is the direction due to positive charge? Heba, am I audible to you?
Yes, sir.
Okay, now let me know the direction. If it is positive charge, what is the direction of electric field at point P? Towards right or left?
Right.
Right. Now, let it be this is a negative charge. And if I have to calculate the direction of electric field at point P, what is the direction? Towards right or left?
Right.
Right, good. Now, let's proceed further. Now, this kind of question, look, a charge Q is placed at the charge Q is placed on the origin. Now, we have to plot the graph between E and X for a region X is greater than 0 and X is less than 0. For this kind of step, look how to do it. Look, for this kind of stuff, just remember one thing. For this kind of graph, you have to plot. First of all, you have to assume electric field towards right is positive and electric field towards left is negative. Is it okay? For this kind of, now we have to plot the graph between E versus X, a charge Q is placed at the origin, and we have to plot the graph between E and X. Look how to do it. So for this kind of question, first of all, we have to assume electric field towards right is positive and electric field towards left is negative. Fine. So E equals to KQ over X square. This is a relation. So E inversely proportional to 1 over X square. Now, first of all, we have to plot the, first of all, just do one thing. You have to put the charge at the origin. Fine. This is the charge you have to put at the origin. So what is the direction? If I take this quadrant, Farhad, if I take this quadrant, what is the direction of electric field due to this positive charge? If I take this charge, what is the direction of electric field, Farhad?
Towards right.
Towards right. Good. So the direction of electric field is towards right. So due to this charge, the electric field, if I, due to this, so away from it's towards right. So the direction of the electric field due to this positive charge, which is placed at the origin, is towards right. Now, if the distance is increasing and it is positive, the shape will be same. The shape will be like this. in all the situation if I have to plot the graph between E and distance. So that shape will be same. So the electric field is towards right and the distance is increasing. Is it okay, Mamuna? The distance is increasing. So distance is in this case, the x is positive. And as I told you, if electric field is towards the right, E is also positive. Then you have to plot the graph in the first quadrant. You have to plot the graph in the first quadrant. Okay. Mamuna?
Yes, sir.
Okay. Hiba, did you get it? Farhat, Alan,
Yes.
Hanifa, Saifullah,
Yes, sir.
did you get it? What I told you? Again, I repeat myself. If E is positive, what we assume, if you get this kind of question, let it be a charge placed at the origin, and we have to plot the graph between X and electric field and X. So for this, you have to assume electric field towards right is positive and electric field towards left is negative. Now, for first quadrant, if we take out first quadrant, now what is the direction of electric field for this? So for this chart, the electric field is towards right, like this. Electric field direction towards right. And if I move this side, the x is also positive. So in which quadrant? You have to take, this is x, E is positive, and for downward, it is negative. For this, x is positive, and for this side, x is negative. Now, if I move towards right, what is the direction due to this charge is towards right. And if I move this side, the x is also positive. So in this case, the electric field is towards right, which we have taken positive, and the distance is also positive. So in the first quadrant, the graph will be plotted like this. Fine. For this, Farhat, what is the direction? Saifullah, sorry. What is the direction due to for left side? What is the direction in this side? Towards right or left?
Right.
For this portion, what is the direction of electric field? Electric field is always away from it, like this. Is it fine?
Yes, sir. Yes, sir. Left.
So for this quadrant, the electric field is towards left. So what I told you, electric field towards left, you have to take it negative. So electric field is negative. Fine. And if I move this side, so x is also negative. If I move towards left, the x is also negative. Fine. So x is also negative. Now, electric field is negative and x is also negative. So in which quadrant? Mamuna, in which quadrant? In which quadrant, Mamuna?
In the third quadrant.
In third quadrant. Fine. So you have to plot this way. Fine. Is it okay with everyone? Hanifa, Hiva, Alan, is it okay with everyone? Or shall
Yes,
I
sir.
repeat? Or shall I repeat again? Saifullah, is it okay?
Yes, it's okay.
Okay, fine. Sorry. Now, let it be a negative charge. Okay. And you have to plot U versus X graph for X is greater than 0 and second X is less than 0. You have 2 minutes and just let me know the shape. Fast. And in which quadrant you will plot them. That's it. Fast. The shape will be same. That is hyperbolic. Just fast. You have 2 minutes to do this question. And write down your answer in chat box. Fast. 1 more minute. First and third. First and third. Hanifa, first and third. First and third. I was, the charge is negative. The charge is negative in this case. I told you the case of positive charge. Just check fast. In which quadrant? Alan, done? First and third. If the charge is negative, the graph will be same. Means you have to plot the graph in the same quadrants. Farhat. Look, how to do. Second, Alan. Great. Fourth and second. Great. Mahmuna, look. This is a graph. Let it be this graph. Okay. So E is positive and E negative. X is positive. X is negative. Okay. Look. Now, first of all, what we have to do it? What we assume towards the right, it is positive. Towards the left, it is negative. Okay. So we have to plot the negative charge at the origin. Now, now what is the direction? What Farhad? What is the direction due to this negative charge? If I talk about this side, what is the direction towards left or towards right?
Right.
For this, the direction would be like this. So
Left.
yeah, the axis, the E is negative because it towards left. What we have taken towards left, it is negative. So E is negative for this side. Fine. If I move this side, so the X is negative or positive? Alan, now, Alan,
Yes, sir.
this side, the E is means it is approaching towards the left. It is approaching towards the left.
Yes, sir.
Now, what is X? X is positive or negative?
So negative.
S is?
Negative.
Are you sure? So it would be in the third quadrant then. Any other? You have written the correct answer, but how? E is negative. Fast. Hello. Hello. Am I audible?
Yes, sir.
Now, Saifullah, it is towards the left. And what I assume towards the left, E is negative. E is
Negative. Yes.
negative. Now, what is X? X is positive or negative?
X is positive.
Positive. X is, because I am talking about this side. Fine. If X is greater than 0, X is positive, but E is negative in this case. So in which quadrant it is negative? And electric field is fourth. So like this. Fine. For X is less than 0. For X is less than 0 for this side. Now, if I take this side, X is less than 0. Now, what is the direction? Farhat, what is the direction for X then less than 0? What is the direction of the electric field? If I take this side, what is the direction of the electric field? Farhat, Mahmuna, Saifullah. Towards right or towards left?
Towards right.
Towards right. Farhat, what is the direction if I take X is less than 0?
Right.
Right. Alan? Alan?
Yes, sir.
What is the direction if I take X is less than 0? What is the direction of the electric field? Towards right or left?
So left.
Left. Hanifa? What is the direction? If I take X is less than 0 means this side. Fine. What is the direction of electric field? Towards right or left?
Right.
Right. Okay. Now, the direction of the electric field for X less than 0 is towards right. Fine. So what I assumed towards right, electric field is positive or negative? Electric field is positive or negative? If I take what I have taken, electric field towards right. So electric field will be positive, but X is negative. So in which quadrant? Mamuna, in which quadrant we have to plot the graph? Electric field is positive, but X is negative. In which quadrant?
Second.
Second. Find this. Is it clear to everyone? Is it clear to everyone?
Yes.
Okay. Alan, is it okay with this? Is it okay this time? How did I plot?
Yes, sir. Yes, sir.
Okay. So these two cases you have to assume for X is greater than 0, what is the direction of electric field? And for X less than 0, what is the direction of electric field? So what did I do? If for X greater than 0, X is positive, but the direction of the electric field comes out to be negative. So electric field is negative, but X is positive. So in which quadrant? In the fourth quadrant. Because electric field is negative this and X is positive this. Fine. Is it clear to everyone? Hanifa, Hiba,
Yes,
Saifullah?
sir.
Okay. Shall I move further? No further. Principle of superposition. Now, if we have to calculate the electric field due to the multiple charges, so what we have to do it? Q1 electric field at O is due to Q1, due to Q2, due to Q3, due to Q4, and so on. This is the, so we have to calculate the resultant electric field. First of all, we have to calculate due to this, due to this, due to this, and we have to sum according to the vector sum of addition. Now, we have to calculate the electric field at the center. Try. Fast. Fast electric field. Two minutes. Fast. And write your answer in the chat box. Okay, first of all, let me know. Okay, just do this question. 2 minutes. Zero. Wait. Done, everyone? Write your answer in the chat box fast. The question is very, very easy. Alan done. Mamuna, Hiba, Farhat, Hanifa. Done. Alan zero. Good. Zero. Let's see. Zero. Zero. Aksha. So let's do it this question. Let's do this question. Now, if I calculate the electric field due to this positive, so along B to D due to this positive charge and due to this towards the negative. So what is the electric field? E equals to ED that is equals to 1 over 4 epsilon. It will come out. What is charge? That is 2e over what is the distance? This is a root 2. By using Pythagoras, we can easily calculate it. So a over this, it would be 4 along b to d. Fine. Now electric field due to negative charges. So electric field EA equals to EC. That is equals to 1 over 4 epsilon E over 2A. Alan, how it is 0? Alan,
So I
how
thought, yes, I thought they all cancel, but no,
They will-
I think
they will get how? This is plus E, this is minus E, this is plus minus 2E, and and
yes, I think I got the signs wrong then.
no. So E equals to ED, that is 1 over 4 epsilon 4E by A along BD, and EA equals to EC 1 over 4 epsilon 2E by A. Now we have to calculate the resultant. So we can write this way. Now this is 2 times of, we can write this is 1 over 4 epsilon 2E this. Fine. And we can write this 2 times of EA. We can write, can we write 2 times of EA?
Yes, sir.
Okay. So net electric field will be EA square plus just a minute. First of all, we have to calculate the total electric field. Total electric field. It means EA plus ED. If you add them, the electric field will be double. All right. 2 times of EA we can write. And 2 times of, sorry, this is ED and B, sorry, EB. This is EB. And EA plus EC, because both have same direction, we can write 2 times of EA, that is equals to 2 times of EA. What is 2 into 1 over 4 epsilon 2E over A. Is it okay with everyone?
Yes, sir.
This is 1. Now further, do. How do we do it? This is 2, this is 2 times of EB. And as what is, just if you look at this, you will get let it be, this is E1 and this is E2. So E1 square plus E2 square equals to 2 E1 E2 cos 90. Is it okay? Is it okay?
Yes, sir.
Now, what is EA? What is E1? E1 is 2 EV. 2 EV. Can you calculate what is E? Can anybody calculate for me? If I calculate it, you will get what is the value? What is EV? 9 into 10 to the power 9. 9 into 10 to the power 9 into 2 into 1.6 into 10 to the power minus 19 over what is A? A is not mentioned here. Okay. Then you have to calculate in that terms only. Sorry, you have to bring the answer in that time only. So EA equals to K 2E over A root 2 square. Fine. That is along, what is the direction? Due to A, along A to C. If you solve it, you will get 4 times of A square. That is also equals to EC. Likewise, ED equals to EB, that is equals to sorry. This is EC. Charges are EB and this. And this is also EB, EB and ED are equal. Now, EA then EA equals to EC, that is equals to K E over A over root 2 square. So it will come out 2KE over A square along A to C, and this is along B to D. Now further. Now net electric field equals to if you sum up them. So EB plus ED, let it be even, that is equals to 2 times 4KE over A square, and E2 equals to EA plus EC, that is equals to 2 times 2K over A square. Now substitute. We can write 8KE over A square, and we can write 4KE over A square. So we can write 2 times of E2. So E1 square plus E2 square plus 2 E1 E2. What is cos? Cos 90 is 0. So E1 square plus E2 square. What is E1? E1 is 2 times of E2 whole square, and this E2 square, it will come out 5 E2 square. So root 5 E2, that is root 5. What is E2? 4KE over A square. So we can write 4 root 5KE over A square. Is it okay? Downward. Is it okay? Is it okay, Hiba?
Yes, sir.
Saifullah, did you get it? What did I do? Due to this, I calculated. Due to this, I calculated. And just I calculated the net of these two. First of all, we have to sum up these two. Then you have to sum up these two. Then we have to calculate the net electric field. Alan, is it okay?
Yes, sir.
Okay. Now, let's move further. Now, neutral point. Neutral point is that point at which the electric field is 0. Fine. Neutral point is that point at which the electric field is 0. So this is plus E, let it be plus 4E. These are the two charges. So the point at which the electric field is 0 is known as neutral point. N is the neutral point. Now symmetrical. Now electric field at the center of symmetrical system is 0. So let it be these two charges. These two charges are like charges. And if I have to calculate, if I calculate the electric field at the mid of these two charges, the electric field come out to be 0. At the center, the electric field is 0. For polygons also, so if the three charges are placed at the vertices of a triangle, and if I have to calculate the electric field at the center, so electric field come out to be 0. Like for 4-point charges also, for 5-point charges, if the body is symmetrical. Now, and infinite point charges are placed on a circle. So electric field will come out to be 0. Now, this question, look at this question. If I have to calculate the electric field at the center due to these 4 charges. So as I told you, due to a symmetry body, what is the electric field at the center? Alan, what is the electric field at the center? Alan,
Yes, sir. We sum up all of the charges.
what is the electric field at the center? If the system is symmetrical, then the electric field at the center is 0. Heba, what is the electric field if the body is symmetrical at the center? Maimuna, Saifullah,
0,
Hanifa,
sir.
Aksha, 0. So if we have to calculate the electric field due to these 4 charges, look. Now, first of all, we have to calculate due to A, due to B, due to C, due to D, and due to E. So if I calculate electric field due to A plus due to B plus due to C plus due to E and due to E, electric field, it will come out to be 0 because for a symmetrical system, the electric field at the center is 0. Is it okay? Is it okay with everyone?
Yes, sir.
Now we have to calculate. So we have to calculate the electric field. The 4 charges are placed at A, at B, at C, at D, and negative of EE. Is it fine? Clear? If I take magnitude both the sides, so can we write the electric field due to 4 charges? Due to 4 charges is equals to electric field due to EE. Can we write? Due to a single charge. What is the electric field? If I place a charge here, what is the electric field? Mamuna, what is the electric field at the center? If the distance is A and charge Q is placed here, positive charge Q, what is the electric field? Farhat, what is the electric field? If I place electric field, look, due to the sum of 4 charges, the electric field due to the sum of 4, the Farhat, what is the electric field due to EA? EE is equivalent to the electric field due to the sum of due to the all charges. What is the electric field due to a single charge? Aksha, am I audible? Alan,
Q by epsilon 0.
KQ over A square. This is the answer. Okay, Mamuna, did you get it? Farhat,
Yes.
Alan, Hiba,
Yes, sir.
Hanifa.
Yes, sir.
Okay. Now, what is the formula for electric field due to a point charge? Fast. Saifullah, what is the formula for electric field?
KQ by R square.
Okay. Let it be 2 charges. If I place, let it be 2 charges plus Q and plus Q. If I have to calculate the electric field at the center, Farhat, what is the value of electric field at the center if the system is symmetrical?
0.
0. Now let's do it. Let's proceed. Just a minute. Now, what do you mean by electric dipole? What is electric dipole? Let it be two charges, opposite in nature, but equal in magnitude, separated by a small distance. This arrangement is known as electric dipole. What is dipole moment? Hello? Am I audible? What is dipole moment? So electric dipole is,
Distance between the two charges.
this is an electric dipole, positive Na and negative. It forms, these are the examples of electric dipole. Now, what is dipole moment? So it is a product of either of the charge between the separation between the two opposite charges. So Q into 2A is the dipole moment. It is a vector quantity having direction from negative Q to positive Q. Its SI unit is coulomb meter. Now try this question, very simple question. You have to apply the formula fast. Which formula we have to use it? We have to calculate the dipole moment. Fast. Two minutes, write your answer in the chat box. This formula we have to use it. Done. Look, what is charge? 2 into 10 to the power minus 3 coulombs. And what is the separation between them? Farhad, what is the separation between the two charges? 3 millimeter from the origin. What is the separation, Saifullah?
6.
6 into 10 to the power minus 3. Multiply fast. 6 2 are 12, 10 to the power minus 6. Okay. What is the unit? Mamuna, what is the unit? Mamuna, what is the unit? Did you get the same answer? 6. Mamuna,
Yes, sir.
what is the, did you get the same answer? 12 into 10 to the power minus 6. All of you are
Yes.
getting the same answer. All of you getting the same answer. 12 into 10 to the power minus 6.
Yes, sir.
SI unit is? Alan, what is SI unit?
So microfarad.
No. Dipole moment. I calculated the dipole moment.
So Debbie.
SI unit is coulomb meter. I told you. Coulomb meter is the SI unit. Okay.
Yes, sir.
This is the answer. Now, electric field due to a dipole. Look. This point is known as axial point, and the perpendicular to the axis of dipole. This is the axis of dipole. The point which is perpendicular to the given axis is known as equatorial point, and along the axis is known as axial point. Now, electric field due to a dipole at an axial point. Now, this is the formula that we have to remember. 2kp, p is a vector, r square minus a square whole square. This is the formula. So, and what is the direction? In this case, the electric field is in the same direction as that of dipole moment. What is the direction of dipole moment? Eva, what is the direction of dipole moment? All of you write your answer in the chat box fast. What is the direction of dipole moment? Not in this case, in general, negative to positive. Good. Alan? Negative to positive. Okay. So, what is the magnitude? 2 kpr over r square minus a square whole square. For a short dipole or ideal dipole, if distance is much greater than a, then 2 kp over 2 kp over r cube. This is the relation. So electric field is inversely proportional to r cube. At equatorial point, as I told you, what do you mean equatorial point? The point which is perpendicular to the dipole axis. So the result comes out so this is the relation for equatorial point minus kp r square plus a square ratio 3/2. Negative sign indicate the direction of the dipole moment and the electric field are opposite. Fine. For a short dipole, kp over r cube. This is the relation. Now try this question. Try this question fast. Fast try this question. The electric field at a point on the equatorial point at a distance from the center of the dipole having r, the r is separation, means r is a distance from the center of the dipole is much greater than. What is the answer? B. Alan, B. At an equatorial point. B. We have to calculate the electric field at an equatorial point. What is the answer? Alan? Hanifa, Maimuna, write your answer fast. It's directly formula based. We have to calculate. I mean, what is the formula to calculate the electric field at equatorial point? Saifullah. A. The negative sign is also in this. There are 4 options. First option is P over 4 epsilon r cube. Second is 2P 4 epsilon r cube. Third is negative P 4 epsilon r cube or negative P 4 epsilon r cube. Which is the answer for short dipole? I just told you. D. Aksha. D is the answer. Mamuna, what is the answer? Mamuna, which is the answer? A, B, C, D. Mamuna, B. Look, at an equatorial point, the electric field is 1 by 4 epsilon P over R cube. Okay, this is the magnitude. But there are 4 options. So this is the electric field. So either A or D. Fine. So, but the direction of electric field and dipole moment are opposite. So this is the answer. D is the option. Fine, D is the option. Okay, what is the formula? What is the formula? Alan, what is the formula? What is the electric field at an axial point? Let me know, please. What is the formula?
So 2p by 4 epsilon 0 r square minus a square by root by into root.
For short dipole, Mamuna, what is that formula for short dipole at an equatorial point? Mamuna, fast. Let me know. Hanifa. Hanifa. Am I audible to everyone? Am I audible to everyone? What is the answer of this question? What is the answer of this question? D is the option. Okay. Okay, what is the direction of the electric field and dipole moment? What is the direction of electric field and dipole moment? Farhat, what is it in case of axial due to a dipole? Farhat, what is the direction of electric field due to a dipole at an axial point? of electric field and dipole moment. Are they parallel or anti-parallel? Farhat,
Yes, sir.
what is the direction of electric field at an axial point due to a short dipole? Means the direction, are they dipole moment and electric field, are they parallel or anti-parallel? Are they parallel or anti-parallel? Farhat, are they parallel or anti-parallel? Am I audible, Farhat?
Yes, sir.
So what is the direction? Just remember one thing. In case of axial, the electric field and dipole moment, they are parallel. And in case of equatorial, electric field and dipole moment are anti-parallel. All right.
Yes, sir.
Is it clear to everyone? Alan, Mahmuna, Mohammed, Saifullah, Mahmuna, Hanifa.
Yes, sir.
Further. Try this question fast. A point Q charge lies on the perpendicular bisector of electric dipole of a dipole moment P. If the distance Q from the dipole is R much larger than the size of the dipole, then the electric field Q is proportional to at Q. Fast. Perpendicular means equatorial point. This relation formula, this formula you have to use it. P over RQ. Fast. Write the answer in chat box fast. Write your answer. The question is very easy. Even I have written the formula. Alan, what is the answer? Farhat, D. Okay, Farhat, D. Please write the answer in chat box. Mahmuna, Alan, Hanifa, Aksha. Hanifa, D. Fast, write your answer in chat box. D. Alan, what is the answer of this question? Alan, what is the answer? D. So answer is D, because E is directly proportional to P, inversely proportional to RQ. Okay, D is the answer. Yes. Did you get it, Mahmuna?
Yes, sir. I wrote the answer in the chat box.
Okay. Now, electric field at any general point, the formula you have to remember means neither equatorial nor axial at any general point. So this is a dipole, make an angle theta. This is a dipole. The separation between them is 2a. Now we have to calculate at any general point, let it be P, making an angle theta with the axis at a distance R. So the formula comes out. Remember this formula. This is the formula. At any general point, E equals to Kp R cube over 3 cos square theta plus 1. This is the formula to calculate the electric field at any general point. Means if you don't remember the axial equatorial point, if you use this formula, axial means theta equals to Farhat. If I take axial point, then theta will come out to be Farhat.
0.
0. Good. Mamuna, if I take equatorial, then theta will be
0.
if I take equatorial, then theta will be perpendicular, means 90 degrees.
90. Yeah.
Oh, okay. In this formula. Till here, is it okay?
Yes, sir.
Okay. Now, Now torque. Now we have to calculate the torque on an electric dipole. First is electric, if the field is uniform. Field is uniform means at every point electric field will be same. Just remember one thing, if you place an electric dipole in uniform electric field, the force experienced by the electric dipole is always 0. Fine. On this, the positive charge, the direction of the direction of the force on positive charge is along the electric field, and on negative charge is always away from it. Means in the opposite direction of electric field. And if you calculate the total charge in electric dipole, it will come out to be 0. The formula is Pe sine theta. Torque in vector form, we can write torque tau equals to P cross E. P vector cross E vector. Now, special cases. Now, there are 3 stable equilibrium. Stable equilibrium means if the theta is 0, it means if dipole moment is parallel to the electric field. Unstable equilibrium means theta is 180 when the dipole moment is anti-parallel to the electric field. And when do we say theta is 90 means the torque is maximum, that is P is perpendicular to electric field. Is it okay till here? Is it okay?
Yes, sir.
Okay. This is the graph. This is the graph. Now, this is the variation of torque with the theta. Because since I told you torque equals to Pe sine theta, so this is the graph. So when do we say the torque is 0? When theta is 0 degree or 180 degree. So if theta is 0 degree, fine, the torque is P is 0 degree. Fine. When do we say the torque is maximum? When theta is pi by 2, that is 90 degree. The torque is Pe. Again, pi is 0, 3 pi by 2 is minus Pe. Again, 2 pi, the torque is again 0. Fine. Is it okay?
Yes, sir.
Okay, Alan, what is the formula for torque what is the formula for torque if I place an electric dipole in uniform electric field? Alan?
P sine theta.
Good. Saifullah, if in case of stable equilibrium, what is theta? Fast.
Unstable 0.
0, good. And torque is also 0. Mamuna, if the equilibrium is unstable, what is theta?
So can you repeat?
If the equilibrium is unstable, what is theta? 180 or 0?
180.
180. Hanifa, in case of unstable equilibrium, the torque experienced by the electric dipole is how much? 0 or it has some value?
180.
Sorry,
180.
I'm not asking about angle, I'm asking about torque. If I place an electric dipole in uniform electric field and if the equilibrium is unstable, then how much force, how much torque will be experienced by an electric dipole?
90.
Sorry,
90.
I'm not asking about theta, I'm asking about torque. How much torque will it experience? 1, 2, 3, 0 what? If it is an unstable equilibrium. Hiva, Farhat,
0.
0. Because in a stable equilibrium, Sorry, try this question. Am I audible to everyone? Please, yes or no, write in chat box. Am I audible to everyone? Maimuna, Alan, Hanifa, Hiba. Am I audible to everyone? Okay, fine. Now try this question. What is given in this question? Theta is 30 degree. Electric field is given 2 into 10 raised to power 5. Torque is given 4 Newton meter. This is SI unit, Newton meter. And dipole length. Dipole length is given, means 2A is given 2 centimeters. So first of all, we have to bring into meters. Now, write your answer in chat box fast. Fast. We have to calculate the charge. Which formula we have to use it? 2 microcoulomb, Alan. Mahmuna, fast. Farhat, Heva, Hanifa, fast. Please write the answer. B. Let's see. Fast. Heva, write your answer. Saifullah, Aksha. Fast. Farhat, are you getting? Now, this formula, PE sine theta. Now, what is P? P is Q into 2A into E into sine theta. B. Now, what is torque? What is torque? Alan, what is the value of torque? That is 4 Q. What is this? Is 2 into 10 to the power minus 2. What is E? What is E? E is
2 to 10 raised to 5.
what is sine 30? Mamuna. Now this is Q. This is 4. Now write 2 to 4 sine 30. What is sine 30?
1 by 2.
1 over 2. So 2 will get. So 2 into 10 is to our 2 centimeter. Electric field is 2 into 10 is to our 5. Sorry. So it would be 3. 2 into 10 to the power minus 3. Q equals to 2 millicoulombs. Is it okay? Mamuna,
Yes, sir.
Hiba, Farhat.
Yes, sir.
This is the formula we have to use it. Now, work done in rotating a dipole. Work done in rotating a dipole. Fine. In a uniform electric field. This is the formula. Fine. Let it be the same figure is. You have to assume the same figure. Let it be a dipole. It is placed in an electric field. And if we have to calculate the work done. So, work done by the electric field. Work done by the external force equals to PE cos theta 1 minus cos theta 2. And work done by electric field equals to PE cos theta 2 minus cos theta 1. And the theta are, these two thetas are the angle. Fine. So if I rotate from theta 1 to theta 2 and theta 2 to means the thetas will be mentioned in the question. Now question. The net force on the net force on an electric dipole in uniform electric field is Farhat. What is the net force on an electric dipole in uniform electric field? Farhat. Mamuna.
Yes, sir.
What is the force experienced by the electric dipole in uniform electric field? 0. How much?
0.
0. This is the formula. Now, just remember one thing. In case of non-uniform electric field means, it means either the field is increasing or decreasing. Fine. If you place an electric dipole, it will experience non-zero net force. Okay. It will experience non-zero net force. Torque may or may not be 0. All right. It depends on the angle. If theta is 0 degree, because we have to use the same formula, P sine theta. If theta is 0 degree, it means torque is 0. If theta is 90 degree, the torque will be maximum. So torque may or may not be 0, but the force will not be equals to 0 in case of non-uniform electric field. Now try this question fast and write your answer in the chat box fast. Farhat, am I audible to you?
Yes, sir.
Okay, just let me know the formula first. Let me know the formula. What is the formula? What is the formula for work done, Farhat?
PE cos theta 1 minus cos theta 2.
Just a minute. Work done equals to PE bracket
Cos theta 1 minus cos theta 2.
okay. Work done by external force or work done by electric?
External.
Okay, cos theta 1 minus cos theta 2. Now fast is work done by external force. Write your answers, chat box. What is theta 1? The work done rotating the dipole by 90 degree. Initially, you have to assume equals to 0. Fast, write your answer. Alan, Mamuna. Question is very simple. Write your answer in chat box. D. How will you do it? E cos theta 1 equals to 0 degree and cos theta 90, that is equals to PE. That's it. Okay. Done. Everyone. Farhad, did you get the same answer? Okay. Saifullah. Alan,
Yes, sir.
did you get the same answer? PE.
Yes, sir.
Okay. Hanifa is not available. Hiba. Hiba.
Yes, sir.
Saifullah, good. Aksha, did you get the same answer?
Yes, sir.
Okay. Now electric flux. What is electric flux? No. Electric flux basically number of electric field lines passing perpendicular to the given surface area. So let it be this is the area and let it be this area having a small area ds vector and making an angle theta with the electric field. So the formula is E dot ds equals to E ds cos theta. This is the formula for electric fields. Electric flux. Electric flux, the definition is the number of electric field lines passing perpendicular or normally to the given surface area. In this figure, the electric field is making an angle theta. So the formula comes out to be E ds cos theta. Just remember one thing, you have to take that component of electric field which is along the area vector. So if you resolve it, just a minute. Sorry. If you resolve it, there will be two components. One is downward, which is perpendicular given surface area, and one is along it. So E cos theta towards horizontal and E sin theta towards right. Okay. This is the formula you have to remember it. Now, so electric flux is number of electric field lines passing perpendicular to the given surface area is known as electric flux. Now, SI unit. SI unit is voltmeter or Newton meter square per coulomb. This formula you have to remember it. It is a scalar quantity. What is an area vector? Just remember, area vector is a vector having direction perpendicular to the given surface area. So let it be this area. And if we have to plot the direction of electric field area vector, then it must be perpendicular to the given surface. So it is a vector quantity. Direction is always normal to the given surface area. Now Gauss law. What is Gauss law? Gauss law states that the net flux through a closed surface, any surface, is equals to the Q over epsilon. So phi equals to closed integral E dot ds equals to Q over epsilon. This is the Gauss law. Is it okay till here?
Yes, sir.
Now, this Gauss law is true for any closed surface, no matter what is the shape and size. Fine. Whether it is cylindrical or circular, or, sorry, whether it is cylindrical or spherical, any surface. But the surface must be closed. Now, if let it be a closed figure having charges Q1 minus Q2 and Q3. If I have to calculate the total flux, so it would be Q1 minus Q2 plus Q3 over epsilon. If it is cube and the charge is placed at the center of the cube, the flux will be Q over epsilon. And if I have to calculate the flux through each phase, so it would be, there are 6 phases. So the total flux is Q over epsilon. So you have to divide by 6. You will get flux through one of the phase. Now, hemispherical surface. If I have to let it be a Q charge is placed at the center of the hemisphere. If I have to calculate the flux through it, then the flux will be Q over 2 epsilon. Just remember this thing. Because first of all, you have to draw the close. First of all, you have to make the hemisphere a sphere. So the total flux will be Q phi equals to Q over epsilon. Just a minute. Fine. So if I have to calculate the total flux through this sphere, then it would be 2 phi equals to Q over epsilon. So hemisphere is half of sphere, then you have to divide by 2. So this is how this comes out. Now flux through a square of HA. So the flux will be Q over 2 epsilon. So let it be a charge placed at a distance A by 2 from the surface of the square having edge A. And now if we have to calculate the flux through it, first of all, we have to make a cube of imaginary cube. And if I have to calculate the flux through 6 phases, so square is one of the face of the cube. So through the 6 phase, the total flux will be Q over capital Q over epsilon. So one of the phase is Q over 6 epsilon. Okay. Is it okay with everyone? Alan, Mahmuna.
Yes, sir.
A minute. Now try this question fast. A sphere encloses an electric dipole with a charge plus minus 3 into 10 to the minus 6. What is the total charge across the sphere? The question is saying a sphere encloses. So first of all, we have to make a sphere encloses a dipole. This is a dipole. First, the sphere encloses a dipole. In case of if we have to calculate the electric flux, you are not supposed to take the charge outside the closed figure. You have to take it within it. First, what is the flux? It's very easy question. 2 minutes. 1 minute, sorry. Write your answer in the chat box. Fast. Write your answer in the chat box. Fast. Eva, Saifullah, Farhat, Alan. The sphere encloses the dipole. What is the net flux through it? Alan? B, 0. B. Mamuna, what is the answer? Eva? What is the total charge? 0. If this is minus 3 into 10 is to our minus 6, and this is 3 into 10 is to our 6. So what is the total charge enclosed by the closed figure is? Flux equals to Q total over epsilon. What is the total charge? 0 over epsilon. So total 0 is the answer. So B is the answer. Correct? Eva, did you understand? Farhat, correct. Mahmuna, Alan. Eva, am I audible to you? Eva, am I audible to you? Aksha, Mahmuna, Saifullah.
Yes, sir.
Okay, what is the answer? Second is the answer because the total charge enclosed by the figure is 0. Is it okay till here?
Yes.
Okay, what is the formula for Gauss law? Phi equals to fast. Farhat, phi equals to. Let me know the formula. Q over epsilon. Scalar, Mamuna, is electric flux a scalar quantity or vector quantity?
Scalar quantity.
A scalar quantity. What's its SI unit? Saifullah, what's its SI unit?
Sir, can you repeat, please?
What is the SI unit for electric flux?
Newton meter square.
Newton meter square and
Per coulomb.
good. If it is a sphere, if it is a okay, let it be a sphere having charge plus Q. What is the flux through it? Alan, what is the flux through it? If a sphere encloses a charge Q, what is the flux through it?
0.
This is a sphere and encloses a charge Q. I'm not telling
Then-
you.
So then Q
Sorry.
by epsilon 0.
Good. Q over epsilon. Not. Further. Is it clear till here? Is it clear till here?
Yes, sir.
Everyone, what electric field? Any doubt? Electric field is a vector quantity or a scalar quantity? Mamuna,
Yes, sir.
electric field is a scalar quantity or a vector quantity?
Vector quantity.
Good. Electric field is a vector quantity. Now applications. You might be familiar. So electric field due to infinitely long straight wire. This is a long straight wire. This is a Gaussian surface. Just remember one thing. If it is infinitely long straight wire, the Gaussian surface will be cylindrical. So electric field is lambda over 2 pi epsilon r. R is the distance. This is the Gaussian surface having length L and distance r. R is the radius of the Gaussian surface. That is cylinder. Further, if I have to plot the graph, it would be hyperbolic. All right. Now try this question. Did you understand what I told you? Applications due to infinitely long. E equals to lambda over 2 pi epsilon r. This formula you have to remember. And the graph will be E inversely proportional to 1 over r. Now try this question fast. There are two parallel infinite line charges with linear charge densities plus lambda and minus lambda. So now what is given? Two parallel infinite. So two parallel infinite line wires having plus lambda and minus lambda. Okay. And the distance between them is 2r. Now we have to calculate the electric field midway at this point at a distance r. Okay, Parat, what is the direction of electric field due to positively charged infinite sheet? Parat, fast, right or left at this point? Let it be O. Parat, what is the direction? Sorry?
Right.
Right. Good. So due to this, right. Fine. Mamuna, what is the direction of electric field at point due to negative charge? Fast. Fast.
Left.
Left. Now, write your answer in the chat box. You have 1 minute. The question is very easy. Due to infinite sheet, I told you the formula lambda over 2 pi epsilon, and just it is a vector quantity. You have to consider the directions as well. Fast. Write your answer in the chat box. 1 minute. You can do it. Very easy question. Alan, fast. Alan, Mahmuna, Farhat, do fast. Write your answer. Alan, what's the answer? Farhat, Mahmuna, Farhat. Farhat is correct. Mahmuna, write your answer in the chat box fast. Alan, Akshay, Hiba, Saifullah, write your answer fast. B. Alan, B. Look. No, due to this positive charge, the electric field, let it be even, that is lambda over 2 pi epsilon r. Okay, Alan and Saifullah, towards right. Okay. Alan, Saifullah.
Yes, sir.
Yes, sir.
Okay. So electric field due to this positive infinitely charged sheet is towards right. That is E1 equals to lambda over 2 pi epsilon r. Is it okay?
Yes, sir.
Yes, sir.
Now, and due to negative, let it be E2 lambda over 2 pi epsilon r towards left. Is it okay? Now, both are equal in magnitude but opposite in direction. So net electric field will be Saifullah. What is the net electric field? Both are equal in magnitude but opposite in direction. Fast. Saifullah.
Yes, sir.
What is the direction? Both are equal in magnitude but opposite in direction.
0.
0. So answer is 0. Farhat was correct. Did you get it? Is it clear to everyone?
Yes, sir.
Okay. Now, electric field due to plane sheet of charge. This is a plane sheet. This is a Gaussian surface. Is it cylindrical? So electric field is equals to sigma. Sigma is the surface charge density. Sigma equals to 2 pi epsilon naught. This is electric field due to a thin sheet. Now, electric field is independent of the distance from the sheet. So electric field is independent of the sheet. It means if I have to calculate r distance apart, 1 meter away from it, 2 meters away from it, 3 meter away from it, the electric field will come out to be sigma over 2 pi epsilon. So it is independent of the distance. Just remember, you are not supposed to make mistake in direction of electric field. So let it be two sheets having plus sigma density and minus sigma density, and there are three areas A, B, C. Now we have to calculate the electric field at A, B, and C. So due to this, positive away from it, sigma over 2 epsilon, and due to negative charge towards it, if I assume left as positive and right as negative, so the sigma over epsilon due to this positive charge and minus sigma over 2 epsilon toward this due to, so electric field are will be equal in magnitude but opposite in direction. Hence in electric field at EA equals to 0. Likewise at EB, so what is the direction? Due to positive towards right, and due to left again towards right. Right we assumed, just a minute. Okay, both have same direction, the electric field will be sigma by epsilon. In the third region, the directions are opposite but equal in magnitude, the electric field will be 0. Okay. Just remember one thing, if the point is 1 meter away from the sheet or 2 meter away from the sheet, but the electric field will remain sigma over 2 epsilon. Now, electric field due to uniformly charged thin spherical shell, there are three cases. First is outside, that is R is greater than R, E equals to 1 over 4 epsilon Q over R square. Sigma is the surface charge density of the thin spherical shell. If R equals to R on the surface, E equals to 1 over epsilon Q over R square, that is sigma over epsilon. Now third is R is less than capital R inside, so electric field is 0. Now this is the graph. This is the graph. I think everyone is familiar with this graph. I hope so. This is the graph at the inside the surface, the electric field is 0 because the charge is 0. Fine. In case of thin spherical shell, the electric field is 0 because the charge is 0. Fine. So means if the distance is less than R, R is the radius of the spherical shell, the electric field is 0. And if we move from the surface, the electric field goes on decreasing. And on the surface, that's sigma over epsilon. Okay? Is it okay with everyone? Mamuna, Alan, Saifullah.
Yes, sir.
Yes, sir.
Okay, great. Now try this question fast. Now try this question. A hollow insulated conducting sphere is given 10 microcoulomb. What will be the electric field at the center of the sphere? Fast. Formula. A hollow insulated conducting sphere is given a positive charge Okay, just a minute. Okay. I forgot this. Electric field near a charge conducting surface. This is a conducting sheet. The last was non-conducting. So in this, the electric field is sigma over epsilon. Last, the electric field equals to 2 over 2 sigma over 2 epsilon, in which case, in which the sheet is non-conducting. Okay. So in case of non-conducting sheet, the electric field is This is the case of non-conducting sheet. So if it is non-conducting sheet, the electric field due to a plane sheet is sigma over epsilon. An electric field near a charge conducting sheet is sigma over epsilon. Both are different. Okay, this is a conducting sheet. The last was non-conducting sheet. All right. Just a minute, ma'am. Okay, let's recall. Then we will over the class. And rest of in the next class we will do it in 15 minutes. Okay, fast. What do you mean by electric flux, Alan? Fast. What is the formula for electric flux? Fast.
So Q by epsilon 0.
I'm not talking about Gauss law. Sorry, Gauss theorem. What is phi equals to E ds cos theta?
Yes, so E is cos theta.
What is the electric field due to infinitely line wire? Mamuna. Fast. What is the electric field due to infinitely long straight wire having surface charge density lambda? What is the formula? Mamuna, please. Heba, Saifullah, what is the formula for long straight wire?
Lambda by 2 pi epsilon naught r.
RZ is good. Correct. Now, Farhat, what is the electric field near a charged non-conducting surface? Non-conducting surface. Fast.
Sigma by epsilon naught.
I'm talking about non-conducting. It is conducting. Sigma over 2 epsilon. Okay. Now, electric field due to thin charged spherical shell at a distance r from the center. Fine. Alan, what is the formula? Having charge q on its surface. Alan, what is the formula? 1 over one over 4 epsilon q over r square. Okay. Mamuna, what is the electric field due to thin plane sheet? Mamuna. Mamuna, am I audible to you?
Yes.
Okay, what is the formula due to a plane sheet, non-conducting sheet? Fast. Whatever you know.
Epsilon, sorry, sigma by 2 epsilon naught.
Correct. Next. Shaifullah. What is the electric field at the center of thin spherical shell?
0.
0. But why?
Oh, why? Because r is
Because charge resides. Because the charge resides on the surface of it. Because the charge is 0. Okay.
yes, sir.
Okay. Just we will discuss 2 more questions on this topic. And okay, just last question. Mamuna, is electric field is independent of R or depends on R in case of electric field due to plane charge sheet? Is it independent or dependent on R? Mamuna?
Independent.
Independent. Correct. Now, bye. Is it everything is clear to everyone?